So we are reviewing this little kiln here, and I'm going to start the video at the end because I figured that all you guys have a lot of stuff to do, and you basically just want the report. You don't really need to see the process, but for those who want to see the process after I've done this little segment, you should stop and take time to get a coffee and then watch how I got to this point, because there's a lot to learn just from the way I did this. So when you get a similar project, or if you get this kiln, then you know what to do to actually get the answers. So it's the Vevor kiln that everybody has been looking at, you know, we all are grateful for Vevor coming out with this kiln, because basically it makes the hobby potter who doesn't want to be in business, they just want to be able to have fun and make a pot every so often, fire it and drink coffee out of it or whatever. So this is the answer. It's a small kiln, 6-inch cube basically, and yeah, you can really get a lot of fun with it. It fires terrifically. It goes up to temperature so fast, and that was a big worry. So if you watch the rest of the video, you'll see I was pretty concerned about this. However, let's have a look, because I just learned how to fire this thing, and I'm pretty sure what's inside is really good. It's a bit hot, 79 degrees centigrade, so don't try unpacking your kiln at that temperature. I'm doing this video because basically I want to see it. I'm too excited, and that's how you feel when you're a beginning potter. You're too excited. But honestly, 79 degrees will burn your hand. So let's have a look. It won't hurt the pot, because that's about 190, no, about 180 Fahrenheit. Oh, great. Any disasters? I'm very happy. Watch the rest of the video, unless you're really impatient. But this kiln worked. It had some problems at the beginning, which I had to sort out. I'm putting this information in this video that you won't have to do that sort out. You just have to watch my video, and then this kiln will work perfectly for you. It's about 400 bucks, and you know, it fires in 45 minutes to an hour and 10 minutes in that region, depending on what you've got in, I guess. And a bisque firing was done in 35 minutes, and I was surprised that that worked, but it did. And this was a firing that took about an hour and 10 minutes, I think. And it went up to I've got, let's see if I can touch this. Oh, it's a bit hot. Okay, can I get that bit out? Let's turn it off, get rid of that fan noise. Okay. It's a bit hot. Okay, I had cone 4, 5, 6, and 7. And you can see they work just the way I do in my gas kiln. So 7 is bending a little bit, which means I think we got to a little bit of cone 6.5, maybe, not quite 7. But that's very acceptable. And you'll see from this firing that I just did, just how I actually judged all that. But basically, what about the pot? You're not supposed to be able to fire things this fast without cracking them. So make sure the clay that you're using is a clay that has a bit of grit in it. We call it grog, but basically a bit of a tooth. So it's not a smooth porcelain, not much. No, B-Mix 5, you can take a chance if you want, but that might crack. And my porcelain style clays that I use, I didn't want to try, so I tried 455 speckle. And I'm sure Standard in Pittsburgh has a similar, sort of speckle stoneware clay body, and all the other clay companies, Columbus Clay Company in the Midwest, Laguna Clay Company has a, I don't remember the number of it, but they have a speckle as well. Number 80 from Laguna is a red stoneware. That would work probably, because this didn't crack. This was green clay yesterday morning, and I bisqued it yesterday, and I glazed it this morning, put it back in the kiln, and so it's out within 30 hours. I've got a finished piece of pot. You have to make sure. I'm just testing it. Oh, I can probably pick it up then. Here you go. It's just my blue glaze with some variegated blue over the top as well. No oatmeal, because I was hurrying. I didn't want to do the waiting till it was thoroughly dry and then dip the oatmeal on. So I dried it thoroughly and just put it in the kiln. And that's a really important thing. You have to dry your pot absolute 100% before you put it in this kiln, because it fires so fast you don't really have a preheat time. You can actually, I'll go into this in another video, you can actually program this kiln basically to have your own segments, but you have to be in attendance the whole time you're doing that. But here's this is now a 5-minute video, and if you want to click off now, you got the information. The kiln is worth buying, and I think that's a saleable piece of pottery that was actually a green ware piece of clay yesterday morning, and it's now a pot that I could sell. Watch the rest of the video. Okay, hi, it's Vaughan at westcoatbellpottery.ca in La Haye, Nova Scotia. I have one of these kilns which I've been testing for like 3-4 days now. I'm trying to get the accuracy of the controller, which is the thermocouple, which is set right in the back here, and I'm double checking on it by putting in my own parameter, which I know is accurate. And I've got another thermocouple coming through this air hole that they put in the kiln, and it's a little loose, so air can still get out that way, and it hangs down, so they're only about 5.5 inches apart, so it should be pretty accurate. There is a lot of discrepancy with the temperatures in this kiln, so my feeling is, I'm going to give you my assessment right up front in the beginning of the video, this is worth it, because it was $400 versus my Paragon, which I'll show you later in the video, which I think I paid $1,800 for, and it's a similar test kiln. The Paragon has a programmable controller on it, so it's a much better test kiln, but if you only have $400, this is the one you can afford, then it'll still do a job for you. You've just got some testing to do, which I'm doing for you, so you know how to do it. Pyrometers can vary, so you should still test your kiln by putting cones in it. This is a cone 06 and a cone 05, fired to what I thought was an 05 temperature, sorry, an 06 temperature, and both of them melted right over, so it's still firing hot, even programmed at 935 centigrade, which is 100 degrees lower than it really should be for those cones to bend. So it involves some testing when you get it, and hopefully my tests are shortcutting that testing you have to do. But I would say that it's a good kiln that needs some, a few test firings first before you put one of your prize pieces in here. But it's cheap. It plugs into a toaster outlet in your kitchen. I had some odors coming out from the first firing, which does happen in every kiln you buy, but after that I've had no odors coming out that I can smell. I'd still have a little, I have my doors wide open when I'm in the summer anyway, so I can get rid of anything that might be coming out from the glazes that way. So my assessment is, it's worth the money, and basically, just like everything in pottery, test. But it's, watch the video now if you want to see everything that I've done. It goes on for probably 35-40 minutes, but I've got some really thorough tests in here that you should watch. And this is a bisque firing I did in here last night in 35-40 minutes, and it didn't crack. So that blew away my entire feeling of, like, bisque firing should be done slowly. This was done in 35-40 minutes, which is pretty much like 1/12 the time frame that you would normally bisque fire at. I want to be able to get at least one coffee mug in here. 5 3/8 inches, and the doorway bends in a little bit there. Let's show you that. See, the doorway sort of has a curve to it with the ceramic fiber. So we've got 5 3/8 inches, so I would say we've got a 5-inch work area, and I think it looks to be about 6 across. Yeah, 6 1/4. So that means I can get one coffee mug in here, or a couple of glasses, or if I buy some shelves for it, I've got some 4-inch shelves for my other test kiln, which is a Paragon. I think that those 4-inch shelves would work in here. And now we're going to have to see what happens when we start it up. Okay, I got it plugged in. And when I turn the on switch on, there's a fan running. I'm not sure what the fan is for, to cool the actual electronics probably. We've got a little digital display here, which I am now going to read the manual on. Here's the specifications for it. So it's 1500 watts, maximum temperature is 1200 centigrade, which is cone 6. Okay, so it's pretty basic. I don't think this is hard to understand. The temperature is increasing now, and I've set it to go to 189 degrees centigrade. It doesn't give you a choice for centigrade or Fahrenheit, so basically it's working in centigrade. You have up and down keys to actually raise or lower your temperature. The U key is when you actually set the temperature, and then this will actually change whatever you want to up or down with those keys. You can set the temperature, and then when you've got it set, you press the P key, and these two flashing lights up here start coming on, and it will actually keep heating. It's now at 53 centigrade, 54, and then when it reaches 189, the bottom two lights will flash, and it will hold at that temperature. So as far as bisquing a piece of pottery, I would say you need to make things very thin, or make sure they're thoroughly dry when you put them in here. So you'd have to, put them on top of a hot surface in the sun or something and make sure they're absolutely dry. It's at 67 already, so it goes up fast. You can set these up and down temperature keys to say 90 degrees centigrade, and then you can hold it for an hour, maybe 2 hours, and that would also dry the piece in here. And then you could press your U key again, so you can raise the temperatures up about 600. And I would actually then set the temperature to go up in small increments, slowly, just so you don't blow a piece up. Because if you heat things up super fast, they can crack. If you use grogged clay, sculpture clay, less likely that they will crack. But if you're doing porcelain, you wouldn't want to fire really fast with this. But it looks like it's a really good test kiln for sure, so I'm going to try just bisquing a piece in here. Okay, we just hit 189. Let's see what happens now. I'm guessing it's going to, residual heat may actually make it go up a bit more. There we got to 190. We're now we're 9 degrees above where I set it. So when the heating to electricity power turns off to the elements, you've got some heat left in the elements, and it keeps it going up. Okay, about 5-6 minutes just passed by, and it went up to 200 degrees, and slowly it's been coming back down. It's at 193 now after about 6-7 minutes. And so my guess is it will stabilize around the 189 that I set it at. So you have to basically assume that the kiln is actually going to reach maybe 10 degrees higher than the set temperature, and then it will cool back down, which is good to know if you're actually firing glaze work, which is precise temperature for melting the glaze. But we're down to 192, so it's working. And now I'm going to make some thin little pieces that we'll put in the kiln and bisque fire them. Okay, the first thing I'm going to say here is I've got two now. I've got my original Paragon test kiln. Both are about the same chamber size. I've noticed that the elements look identical, and the chamber looks to be the same size, so initially you don't see much difference at all. But I do know that the controller on the Paragon kiln here is controllable for ramps and cone fires and all that kind of stuff. So this one, my original test kiln, has a lot more options and control. This one has basically up and down, set temperature and go up, and that's it, no segments or anything. So it's going to be a little harder and time consuming to actually do a firing. If you want to take it up to a certain temperature, then let it sit for 5 minutes, then take it up to another temperature, you gotta keep coming back and programming another segment. But that's fine, you know. So basically you just got to be with the kiln when it's firing and all that, whereas the Paragon one here, you can just sort of set it and leave it and it's done and all that. So fire it in the studio while you're working, no problem at all. Keep them 10 inches from the back of any shelf and all that. This one's on wheels, so I pull it out when I actually fire it. This is on a slab roller, it's got 9 inches at the moment, so I'm just going to pull the slab roller another inch away. But it's super insulated, so I bet there's no problem anyway. You could plug this into a toaster outlet. So basically it's fine. So I read the instructions, because there isn't much with the this Vevor kiln, but with that one, you're supposed to fire it to cone 018 first to temper your elements, because it produces an oxide on the elements that prolongs the life of the elements. And then after you got to that cone 018, then you would actually, which is about 13 to 1400 degrees Fahrenheit, 650 I think centigrade, maybe 750, something like that. I'll look it up. Why don't I do it while I'm talking to you? So cone 018 is 734 degrees centigrade. So I'm going to fire the little Vevor kiln to 734 centigrade for its first firing, nothing in it. Let it cool down. Then I'm going to fire it to cone 05. Which is an actual Bisque firing, and that's all your tempering, that's your first firing basically, with nothing in it as well. So you've got to do a couple of little firings before you start it up. It only takes an hour and a half to get to temperature anyway, but that's stoneware, so this will be like an hour-long firing for each one, and then cool down. So I bet I can do both during the day, so that's what I'm going to do. I also have an accuracy thermocouple pyrometer here, so I'm going to check the accuracy of the kiln thermocouple to make sure that you know, we're within 5-10 degrees at least as far as accuracy is concerned, because that makes a big difference if you actually are firing to a cone, and you might even be a cone or cone and a half above or below what the actual thermocouple is reading as far as that. So we'll fire it with this, and then I can double check the accuracy too, and it will stop at 734, I hope. We'll see. And I've got my pyrometer here, is already reading 87 degrees. So my T1 is the outside temperature here, because I don't have that thermocouple in the actual kiln. But we're reading 96 degrees centigrade, and on here it's reading 37 degrees centigrade. So that's interesting. Degrees centigrade versus, so it's already boiling point, but my thermocouple is really close to the elements, so that's probably what that's reading. The spy hole here at the top, I've got the pyrometer in there, and it's a bit close to the actual kiln. But I've got another one of these thermocouples to check as well, just in case. Hey, it's 22 minutes and the kiln is now at 734 centigrade. 736 actually. It's set at 734, but it's gone up a couple of degrees. This one is reading 851, which is 120 degrees difference, and the parameter's coming all the way down near the bottom. I'll show you when I open it up. So that tells me that it's possible, and I'm going to let this even out for about 10 minutes to see whether this evens completely. It's possible that because it's close to the elements all the way down, that it heats up a bit more. So we've got 736 and 853. Will we get it evening out? Let's go for another 10 minutes and see what the difference is. That's actually 35, 50, that's 120 degrees difference centigrade and all that. So I just want to check, see whether we even out. I just want to also say that this doesn't have any odors. And I did do a little kiln firing in the new studio. It felt funny bringing this down, it's like a suitcase. But anyway, I brought it down from the new studio to the old studio, where I did in the new studio about 5 days ago, I did a little test firing up to 400 degrees to see whether it was working, because I just got it out of the box, want to make sure nothing's wrong. So probably the odors that came out, there wasn't much there, but I did notice something. but that's just the the sealants and stuff probably between the brick that actually make it fully insulated. So that's natural to get some of that. So you might want to do the first firing in an outdoor area, just to get rid of those fumes, because this firing there's nothing. I'm not smelling a thing. Okay, this is about 6 or 7 minutes later. It's still at 8:52 and that's at 7:35. So I'm feeling that there's a big difference between either the tiny chamber, so it can't be the difference in different places in the chamber, it just must be the thermocouples that are put in here. So are they calibrated correctly? And there's no way of changing the calibration on the one inside, and this one was working fine in my gas kiln. So I think that this one could be out, 10 degrees possibly, but I can't imagine it's out 110 degrees. So 8:51 at the moment, 7:34. They just haven't changed. So I think this kiln fires hot because the thermocouple is not calibrated correctly, and I can check that by putting a cone in there. So that's my next firing. I'm going to fire it up to cone 04, probably 06 or 05. I'll see whatever cones I have, and then basically we'll see if that cone falls, and see how accurate it is. I just reprogrammed it now by pressing the P button, by pressing the U button and taking the temperature down to 30 degrees. So now I'm trying to see whether the kiln will just fire downwards to 30 degrees by obviously not turning the elements on, because it's already way 731, it's way above the temperature of the actual kiln. So let's see what happens. P is flashing. And we'll see now it's going down. Yep, it's down to 728, 27. So the kiln is now firing down. We'll see how long it takes to cool off. And the fan is still running, so that tells me that the heat from the chamber is being dispersed outside of the kiln. Down to 724, it's lost 10 degrees already. So this is my newer version of this device. It actually is good to check the accuracy of my older version of this, and we're already up to 462, and it's at 595 in the kiln. So let's see if these even out at the same temperature, because it may be that the older version of this device didn't work very well. Right, we're up to 590, 93. So it looks like my other one was pretty accurate. We're up to 610. When this one starts dropping, we'll know we reached the peak temperature, and we are now close to 50 degrees off in the thermocouples, slowing down. So we may have okay, 630. Check the old one, but that's not in there. Coffee, please. I need some coffee. 634. And that's 28 plus 35, so we're already 65, 70 degrees off. So we know that the pyrometer that they've supplied in this kiln is not as accurate as this one. And who's to say that theirs isn't better than this one? I don't know, but I'm just reading 2 of these versus 1 in the kiln. Both of these are reading it's a lot hotter than the actual thermocouple in the kiln is telling you. So there's lots of questions here that we're not able to answer really. It could be that the people who made this kiln know that the actual temperature, because it fires so fast, say if centigrade, well we use Fahrenheit, but centigrade, 1220, cone 6. And in actual fact, in my gas kiln, because it fires a bit slower, and it's a big, huge area, I reach cone 6 at about 1199, which is 21 degrees lower than they say it reaches, but that's centigrade. But if I fire the kiln super fast, it'll be like 1220, 1225, 1230. if you fire the kiln really fast. So cones are what you go by. The temperature in the kiln is not as accurate as going by cones, because cones tell you the amount of heat that you've applied to your glaze, which a cone is actually made of glaze. So it's better to go by cones. But we're reading 631 now, so we're starting to go down. So 31 versus 551, 631 versus 551. You're talking 80 degrees difference between these thermocouples. Sorry that took a long time to explain, but that's really important if you want to successfully glaze your pieces. Okay, so the kiln is now reading 159 degrees centigrade. I've set it to get down to 30, and it's 12:32 now, so this thing has taken 2.5 hours of cooling from 10 o'clock until 12:30 to get down to a temperature where I feel like I could probably open the door now without damaging anything, because there's nothing in there, just the actual elements and the kiln brick itself. The pyrometer that I have, just as a test to show you, I laid on top for the other one. There's two in this device, this what's it called, the thermometer. But I've got one in the kiln and one just resting on the top. So the outside shell of the kiln is reaching 42 degrees, which, you know, in Texas, that's just a hot day. So I didn't feel worried about the actual temperature of the kiln being too hot to have sitting here. It's about 9-10 inches from the back of the shelf anyway. So 42, what's the inside? Number one, it's reading 200 degrees centigrade, and this is reading 158. So there's still 42 degrees difference between the pyrometer that was in the kiln to this device here, which I think these are pretty accurate. I've got two of them and they're both reading the same. So that I'm just reading the thermometer, but pyrometer thermocouple, get it right, inside the kiln is not as accurate, I don't think, because now it's down fairly low and there's still a big difference in temperature. So let's open her up, turn it off before I open it up, because we don't want to risk of any electric shock. There shouldn't be, but anyway, turn it off, take a look. So the inside, hasn't changed much, it looks just the same. I'm going to place my cone pack. I've got this little cone pack here. I've got an 05 and an 06. So this is 06, which will bend first, and this is 05, which will bend next, to see how accurate it is. So I'm going to place those in here. All right, so in centigrade, 300 degrees an hour is the maximum, they say. So we'll use that one, and down to cone 06 would be 1023 degrees. So I'm going to set this to go up to 1023 degrees. Turn it on again. So we're going to press U and raise the temperature. 1023 degrees. I'm going to make it 1025 P. Now it should start going up again. The temperature is now 144, so with the equal sign flashing, the temperature is increasing. So this is a test just for the cones. Okay, it is 34 minutes later, and it's already at 1024, 1025. That's pretty incredible. And I don't know if my little Paragon here could do that, I'm not sure. But anyway, what does that mean? It means you can do a bisque firing in 34 minutes. Is your pot going to survive if it's bisque fired that fast? That will be the next firing that I'm going to do, because I have a piece ready to get in there, and I'm going to put it in and let it do its thing. There are two things that I have to be aware of, because at about 425 degrees to 450 degrees Fahrenheit, which is about 250 centigrade, there's a cristobalite change in the clay body that you're supposed to go through that temperature change slowly, and again you're supposed to do it at around 600 to 650 centigrade, and you're supposed to go through that period slowly too, because the clay changes chemically and loses its water and things like that. So, because clay is a compound of silica, aluminum, metals, and water. But anyway, and that's what changes it to ceramic around 650 centigrade. But anyway, those two are supposed to go through slowly, and we don't know, because this kiln isn't going to do that. It's going to shoot straight up there. So I'm going to sacrifice one of my little T-balls and just do the Bisque wiring the way the thing just goes up in temperature and see what happens. If that doesn't work, if the piece cracks, then I'm going to try firing where I just fire it up to 450, about 225 centigrade, and hold it for like 20 minutes, and then I'll reprogram it to go up to about 650 and hold it for like 20-25 minutes and see whether that works as well. But maybe it's going to work this way. So what do we see? Here's my pyrometer on the actual this thermocouple that's inside is reading 1135 degrees centigrade. That's 110 degrees hotter than this thermocouple is telling you, which is the one supplied with the kiln, which is reading 1023. And between 1023 and 10, I set it at 1025, but it's now reading 1023 because it's holding, so it's stabilizing out. So we're still 110 degrees hotter on my supposedly more accurate thermometer here. The cones will tell us inside, because they will melt if it really is that temperature in there and all that, because they're supposed to melt at 1023, and then again probably about 1090, I would think, for the cone 05. But anyway, we're going to see. So it's been soaking for a few minutes, and I guess I should give it a few more minutes. But that's, Oh, and the other one on top is reading 49 degrees. So the shell of the kiln is at 49 degrees, and you don't have to worry about burning the house down at that temperature, because that's basically not hot enough. It's too hot for me to touch, I'm sure, but basically it's not hot enough to catch something on fire on the shell of the kiln. And that's because you have a nice fan working in there that's blowing the air out to keep everything cool on the shell, which is a good feature there. This is down to 68 degrees centigrade, so it's a bit too hot to touch something, but that's safe enough to open up the kiln. So I uncracked it. Let's turn it off just to be sure. And it's good news and bad news. Good news is this sucker can get up to temperature really easily. So you have no problem reaching cone 6, I would guess, in this kiln, because it got to Bisque temperature in, I don't know, 45 minutes, whatever it was. And basically it's cooled down in about 4.5 hours, I guess. So you could do a couple of firings a day in this kiln, get a mug in the morning, mug in the afternoon. But the problem is the thermometer, or the thermocouple, is not reading accurately. So I set this, whatever it was, and I put 2 cones in, 1023 centigrade. Cone 6 should have bent over, because that's the normal way it would bend over at that temperature. And it was reading 1023, and is this too hot? No, it's not too bad. Cone 6, ignore the white one, that was an old one from a different firing. Cone 6 is that, and that is melted completely. That should not be like that. Cone 5 is melted completely, and that should not be like that. But this kiln, great news, it gets to temperature easily, so you can do pottery in it. We have to work at getting the actual temperature correct. So I would say that we'd have to do some test firings with cones and just see what temperature it gets to cone 06 and what temperature it gets to cone 6. And if you do any other firings, any other temperatures, 04 or whatever, you're just going to have to put some cones in and play with it to see what temperature it will reach. Because there is no spy hole in the front, so you can see a cone bend over. And so it's really a matter of just trial and error, which is what I'll be doing next. Got some self-supporting cones 03, 04, 03, 02, and 01. So I'm going to put these, and I've got these cute little kiln shells. Thank you, Freddie Moretti, who sent me these two little kiln shells like this that fit in this kiln perfectly. They're for my other kiln. I'm going to put them on here because I don't want to ruin the bottom of the kiln there. So I'm going to put 01, 02, 03, and 04. So I've got 4 cones in there, and here's the pyrometer that's hanging from the top here. It's hanging halfway down in the back corner, and the other one is just sticking up about 2 centimeters on the left hand corner. So there's no difference in temperature in those 2 places in this tiny little kiln. So my thermocouple from the top with my little, I don't remember the name of this device. Can't remember. I'll look it up and see what this was, but this is very accurate in my other kiln, so it's accurate in here too. So their the actual pyrometer in their kiln is not reading an accurate reading. This one is. So we'll go by this. So at 1023, this is way overfired. So I'm going to program this now at let's say 950, because there was about 100 degrees difference, remember, when we were looking at the 2 thermocouples. So I'm going to program it at 950 and see how hot it gets, and then my little sensor here, I'll be able to tell if it's at 1023, and we'll see how that goes. So stay tuned. Okay, it didn't take long at all we're talking 35 minutes, max to get to temperature for Bisque firing. And it's reading 950, that was my target, and it's actually on 950. This one is reading 1061. So we have a dispute between about 110 degrees. So that's the difference. So my feeling is this kiln is firing about 110 degrees hotter than the actual pyrometer in the actual kiln is telling you. So this would be cone 05 just about, and I've got 05 in there. I put one in right up just before I started it up. So we've got 05, 04, 03, 02, and 01 in there. So we'll have a really accurate kind of reading, I hope, from just the way the cones behave. So when I do my Bisque firing, let's say cone 05 went over in this firing, then I would know to set this kiln at 950 to do a Bisque firing. But cone 05 may be still standing, I don't know, but at least we'll know then that 950 is a safe for 06. The thing I wanted to show you is that we have the thermocouple laying on the top is reading 53 degrees centigrade, even though it's right at Bisque temperature inside. So the kiln does not get super hot on the outside. Okay, 06 bent over, hooray! 05 was just beginning to start bending, and the other cones weren't bent at all. So this temperature of about 940, 950 is perfect for a Bisque firing. So at least we've established that. Okay, this is a T-ball that I'm going to leave in the kiln because it's warm in there. So this will thoroughly dry it overnight. And the cones are still there, but they're a bit hot, so I'm going to take them out in the morning and just fire this kiln. I'll put an 06 cone in there, and we'll fire it at 935 and see just that 06 will bend over, and then we've got a Bisque firing. But is the piece going to survive such a fast firing? We don't know. But we'll know in the morning. And for you guys, it's right next. And 06 and then 05 behind it. And I'm going to fire it just straight. I mean, I'm sacrificing this piece because it may crack because of the firing being too fast, but we'll see. So I'm going to set it to this temperature, 935. It's going to start firing now. So we've established that my pyrometer seems to be more accurate. This is a real Bisque firing now, just set the way the kiln is supposed to rise from the factory setting, which is too fast in my opinion, but we may be surprised. The reading was 100 degrees difference between this pyrometer and the one that I have here, and even now as it's cooling, I've got it going down to cooling, it's 795 in the machine and it's 882, 881 now on my pyrometer, which we double checked with another one to show they're both accurate. The great thing about this little kiln is you can move it any way you want. It was in the way on my slab roller, so I just picked it up and moved it over here. That's very clever. It's still a little bit hot to open, but I'm going to do it anyway because it's 6 o'clock and I want to go home. Well, my piece survived, but the cones, the 06 is melted completely and the 05 is over. So that tells me that the cone 05, 1062. So 1062 means that the 05 melted would still be like this. This is flat and melted completely. It's not too bad actually for 120 degrees centigrade. Anyway, that's the 05 and the 06. So I'd say we're still way overfired for Bisque firing, and that was putting it at 935. So how low do we have to go to get an accurate Bisque firing, which is around 1020 to 1070? But the pot survived. I'm quite happy about that. Bisque firing, 40 minutes. Wow. But the accuracy of the glaze firing is what worries me, because we've got to be able to make sure that glaze doesn't blister and bubble from overfiring. So I'm going to have to get some accuracy in this kiln before I do the glaze firing. Stay tuned. Okay, I've got it glazed with bright blue and variegated blue over the top, and I've got 4, 5, 6 and 7 cones in there. And I'm going to fire it using my own thermocouple as a gauge to see what temperature it gets to, and then we'll know what temperature the thermocouple that's supplied with the kiln is reading to get an accurate setting that we need to use with this kiln. My thermocouple is much more accurate, and we'll be able to guide theirs using mine. So stay tuned. 10 minutes in and the kiln is reading 68 centigrade. And my thermometer is reading 253 centigrade. So you can see where the problem is. My thermometer is hanging in the center kind of more area of the kiln, and this thing is on the bottom, their thermometer, so it's probably reading the temperature of the floor of the kiln, which is cooling the temperature sensor. So I would think that, you know, if it was sort of higher up, or it was from the top of the kiln hanging down like mine is, it would be a more accurate reading. But that's one of my suggestions. Okay, we're about 20-25 minutes into the firing now, and you can see the difference on the temperature things. We've got 200 degrees difference in the pyrometer on the floor, which is supplied with the kiln, and my pyrometer hanging from the ceiling, and they're only 5 inches apart, so something is making their pyrometer read a cooler setting. Okay, now look, things have still kind of, 150 degrees difference in temperature, but there were 200 degrees. So the hotter it's getting, the more the temperature is evening out. Okay, we're already at Bisque temperature as far as that kiln is concerned, but we've already discovered that Bisque, which is 1025, actually is reached around 850, 900. So the temperature in the kiln is 1009 on the haircut thermometer, and on mine it's 1146. So we are less than 150 degrees apart now. So it looks to me like as it increases in temperature, it actually is evening out. but it's crucial that I don't go over 1200, and we've only got 50 degrees to go, so it's not going to even out enough. And that's why I set it at 1100, because if my pyrometer gets to 1200 and theirs is still not reached 1100, we will be overfired again. So for the next 10 minutes I have to watch this, because it goes up that fast. You know, you can see it as it's increasing. It's less than 1 degree a second. Yeah, you know, 20, 21. So it's 1 degree every couple of seconds. So theirs goes up really fast, but we're at 1157. So I'm watching this crucially, so I do not want to go over 1200. Okay, I just used I pressed P first to stop it, and then I actually pressed the U button to actually lower the temperature by 25 degrees on the kiln, because we are really close. So now the difference between the two, 50 degrees and 33 degrees on my pyrometer, I'm hoping to even it out around 1200, and then I'm going to slowly increase it a little bit to about maybe 1225 on my pyrometer, because that's the temperature when my Bailey kilns that I actually fire to, 1225. So we're going to try, and we've got my safety temperature in there at 1200, and now I've lowered it on the other kiln to 1075, and we should be there in the next 5 minutes. Okay, the kiln is only 1 degree off in its heating cycle, and it will hit 1075 that I've actually set it at. And the other one is reading 1193, which is below what my safety sort of temperature, because I didn't want to overfire this. And I think the kiln is already it's just dropped a degree, so it's probably trying to soak at this point where it holds its temperature and evens out. So we could let it go for like 5 minutes here, and then I'm going to set it to go up, so that I think we're at 1196 on my thermometer and 1074, so we're still 120 degrees difference in temperature between my thermocouple and theirs. So I think we have to assume that you're going to have to set this kiln between 1075 and 1100 to actually get a cone 6 accurately, which shouldn't be, but that's the way it is. And so you can use this kiln. It's actually perfectly functional. It does a great temperature rise, but you've got to do some tweaking, and that is the difference between spending $1,800 on a test kiln or $400 on this kiln. You need some tweaking, and thanks to YouTube, of course, you get all this help from people, because I'm not the only one who's testing out this kiln. Look at that, 1075, and it's holding temperature. And mine is reading 1192, so we're talking 25 plus 91, so that's 120 degrees difference really. So we're just going to let it sit for 5 minutes. Then I'm going to press the P button and raise the temperature by about 20 degrees, I think. I just reprogrammed it by pressing the U button and raising it to the 1100 on the kiln, and my thermometer is reading 1194, so I'm going to try and take it up to 1100 and hope that my temperature on my kiln pyrometer will go up to about 1220, and 1225 is optimal, I think. Okay, things have been rising a little slower because it's quite high temperature now, but we're reading close to 1100, 1097 and 1212 on my pyrometer. Just to give you an idea, the outside of the kiln with my other thermocouple laying on the top there is 54 degrees centigrade, so that is a hot day in Australia. I just raised the temperature of the kiln itself to 1110 because we seemed to be stuck at 1098. It hadn't increased to the 1100 I'd set it at, so I'm going to give it to 1110, and then now we should see some increase because the kiln controller is recognizing it's got to get up to a higher temperature. Yeah, it just went to 1099, and my thermometer is reading 1215, so I don't want that to go above 1225. So that should mean that the kiln should get to 1110, and it'll be at 1225 on my pyrometer. It's a super fast firing, so the cone shouldn't bend till maybe a bit hotter than 1232 for cone 6. So I could even push it to make it go to 1230, but we'll see what happens. I've got cones inside to tell me anyway. So we're at 1223 on my parameter and 1108 in the kiln. I've got it set at 1115 to go up another 7 degrees. We'll be at 1231. 1232 is the actual temperature that cone 6 is supposed to bend over if you go up at 108 degrees an hour. This kiln went up at 1,000 degrees an hour, but anyway, we'll see what goes on here. But I'm going to let it go for about 5 minutes at 1232 and see what we have. Okay, the kiln is now at 1119 with the Vevor thermocouple, and my pyrometer is reading 1230 to 1232. It's fluctuating a little bit, and so we know that a true cone 6, which is 1232 at 108 degrees an hour normally, but this thing goes up 1,000 degrees an hour, so I can get it 1119 on the Vevor kiln is equal to 1232 on this thermocouple that I own, which I know is pretty accurate.